Okay, at this point in time, we're pros at solving quadratic equations. Therefore, we're going to move on to solving a little bit more difficult problems like polynomial equations. So this is 6.4, solving polynomial equations. There's a lot of different ways we could do it. I'm going to stick with what I feel the most basic method is, and that is kind of using a bunch of stuff we've learned. So we're going to use graphing, we're going to use the degree, we're going to use synthetic division, and either the quadratic formula or completing the square, whichever you are more comfortable with, you can pick. Okay, so we're going to use all of that just to solve one equation most of the time. Sometimes we'll only have to use one of those scenarios. Let's look at some examples here. So like this first one, we're going to solve x to the third plus 3x squared equals x plus 3. When we solve this, just like with quadratic equations, we want to get it equal to 0. So I'm going to subtract the x and subtract the 3. So we have x cubed plus 3x squared minus x minus 3 equals 0. I'm going to go to y equals. Okay, and we are going to, so my calculator went to y equals, and we're going to go to the graph. Now, we're going to use the degree here. The degree, as you can see, is 3. The highest exponent is 3, which means we need 3 solutions. The nice thing is, looking at our graph, we have 1, 2, 3. We have 3 x-intercepts, which means I can just calculate those 3 x-intercepts, and that will be my solution. I actually put this on Desmos. Looking here, you can see very easily that it crosses at -3, -1, and 1. So those are my zeros. Or x equals, oh, I didn't put it on here. Thought I did. X equals -3, -1, and 1 are my zeros. Now, it won't always work out that nicely where you can just look at where it crosses the x-axis. So you're going to have to know on your graphing calculator how to calculate it. And I know we've done this before, but just to review, there are 3 zeros, so we're going to have to go through this process 3 times. So we're going to hit second trace. We're going to calculate the 0. I'm going to go to the 0 I'm trying to find, which in this case is that one. This is about as close as I can get to it. So I have to go to the left of that 0. So I'm going to hit my left cursor once. I'm going to hit enter. I'm going to go back to that 0, and then I'm going to hit my right cursor once and hit enter. You don't want to hit it more than once because you don't really want that point to go past that turning point. So we're going to hit enter and then guess. X equals -3. There is 1 0. So I have to go through this process, like I said, 3 times. So I have 2 more times I need to go through this. So it's second trace 0. I'm going to go over to the right to the other 0 I'm trying to find. Looks like that's as close as I'm going to get to it. I'm going to go to the left of it. So I hit left, hit enter. I'm going to go to the right of it. I'm going to hit enter, and then I'm going to guess. And I have the 0 of -1. Okay, and one last 0 we have to create, or find. We're not creating it, it's there. Would be this other one here, which we've already established is at 1. Whoops. Go to the 0. That's as close as I'm going to get. Do the, oops, I didn't go to the left of it. We'll see if it works. Haha, it works still. All right, 1. So x equals 1 is our other 0. In that case, we're done. It has degree 3. There's my 3 solutions. Just so happens they're all 3 real. Now, it's not always going to be that nice and easy. Remember our first step, get it equal to 0. So pause the video, do that. And here's your check. So x squared minus 2x, or x cubed minus 2x squared plus 3 equals 0. When we graph that in our graphing calculator, we get that image. We'll have to calculate that 0. And it is at -1. Is that 0 there once we calculate it? But it has degree 3, so how many solutions is it supposed to have? 3. The problem is there's not 3 x-intercepts. The reason there's not 3 x-intercepts because all 3 solutions aren't all real. So we have this one real solution, means the other 2 are imaginary. So we can then use synthetic division and this 0 to make the problem into a quadratic, which we know how to solve. Okay, so what we're going to do, x equals -1, so the other 2 solutions. Okay, so with this, we had x cubed minus 2x squared plus 3 equals 0. We solved it by we graphed it, and we found it had one real 0 of x equals -1. So what we can do is, instead of using synthetic division, which I think in the video that I said we should do, or in the other video I think I said we should use, we actually need to use long division here. And we can do that by saying, all right, x equals -1 is my 0. So that means this creates a factor of x plus 1. So because this is a 0, this factor of x plus 1 should be divided into x cubed minus 2x squared plus 3 evenly, meaning there shouldn't be a remainder because it is a factor. So then we can just go through and use long division. Well, x cubed divided by x is x squared. So then take x squared, multiply it by both these terms. We get x cubed plus x squared. Subtract them both. I'm going to try to go through this quickly. We just took a quiz over this, so you should know this material rather well. The only thing here, once we get everything, then we have to multiply by -3x here. So we get -3x squared plus 3 minus -3x squared minus 3x. So like this came up in 6.3. Remember, these aren't like terms, so I can't subtract them. So really it's 0x minus a -3x. So we have a positive 3x, and then we bring the 3 down. So that's where this 3x plus 3 came from. Multiply both by 3, and that's 10 here. So that takes us, you might say, all right, great. So you just proved what we already know, that x plus 1 is a factor. You're right, I did. But remember, what's the purpose of this? We're trying to solve this polynomial equation. So we're trying to find the 3 values of x that make this equation true. Right now, we only have 1. It's x equals -1. The other 2, we're going to have to use and find by using the quadratic formula. So I'm going to go back to the other video now, and you can hear that explanation of how we can now use x squared minus 3x plus 3 to find what the other 2 solutions are. Completing the square. So looking at it, I chose quadratic formula because personally I think it's easier than completing the square. Opposite b is 3 plus or minus square root b squared minus 4 times a times c, all divided by 2a. So that will simplify to 3 plus or minus the square root of -3 divided by 2. Remember, to get rid of that negative underneath the radical, we take the I out. So our final answer is 3 plus or minus I square root of 3 divided by 2. And the plus and minus are my 2 solutions. 3 plus I squared root of 3 over 2 and 3 minus I squared root of 3 over 2. Great, let's look at another problem here. Now, one thing I want to show you before we necessarily look at this is there are some exceptions. Like this problem, if we had x to the 4th minus x squared equaled 0, and that's our solution, or that's our problem, and we had to find our solutions. We would do that by looking at our graph. You might say, well, hold on, this degree is 4, which means we're supposed to have 4 solutions, and from what I can tell here, there's only 3. Well, you're right, but one of these zeros has a multiplicity of 2. Multiplicity of 2 zeros touch and turn. They bounce on that x-axis always. So that is so this does have 4 solutions. They're at -1, 1, and 0 with multiplicity of 2. Or you could write 0 twice. I didn't have an example of that on my notes, but I did want to show you in case you're working through the problems and you see that. You're not going to have an imaginary solution there. All right, now here I want to solve x to the 4th minus x squared equals 12. Why don't you pause the video and try this? At least the first part, get it equal to 0. Okay, there are actually 2 different ways we could approach this one. We could do what we've done with all the other ones. In step 1, we could graph it. When you graph it, you'll see that it has 2 distinct x-intercepts, both at positive 2, or at where x is positive 2 and where x is -2. It does not bounce on either of those x-intercepts, so we know that it only occurs there once. Then what you would have to do from there is use long division twice to get that to get this quartic polynomial down to a quadratic, and then use the quadratic formula. Now, while that's totally capable and you can definitely do it, there's another way that we could approach it. And I kind of want to show you that. If you want me to explain the other way in class, I gladly will. I'm not going to do it on this video because it'll take me about 7 or 8 minutes just for that part. So with this, you might say, all right, well, there's 3 terms. And I remember like quadratics always had three terms. It was x squared, it was ax squared plus bx plus c, right? Is the standard form of a quadratic. You might say, well, this is very similar to that, but it's x to the fourth is my first term and x squared is my second term, and no x is my constant term there, negative 12. You can actually factor this to solve it. And it's not as hard as it might think. So just like we did factoring before, what can we multiply to get x to the fourth, right? Well, before, to get x squared, we did x times x. Well, to get x to the fourth, it's x squared times x squared. Okay, so that's x to the fourth. And then remember before we said, all right, well, what were my factors of my c term? So factors of 12, in this case, negative 12, that would OI to negative 1. Well, all my factors of 12 are 1 and 12, 2 and 6, and 3 and 4. 3 and 4 are the only ones that would OI to negative 1 here. So it just so happens that we need to have a negative 4 and a positive 3. Okay, so that would essentially be our factored form of this equation. We can check it out. X squared times x squared is x to the fourth. X squared times 3 is 3x squared. Negative 4 times x squared is negative 4x squared. 3x squared plus negative 4x squared is negative 1x squared. And negative 4 times 3 is negative 12. Now, unfortunately, we're not done, right? Just like when we solved quadratics by factoring, what did we have to do after we had it factored to solve it? Well, remember, we had to take each factor and set it equal to 0. So we have x squared minus 4 equals 0. And we have x squared plus 3 equals 0. And now let's solve each of those factors. Add 4, so we'll get x squared equals 4. Subtract 3, so we'll have x squared equals negative 3. And then to solve, we square root, right? So here, don't make this mistake. Remember when we square root x squared, it's a positive 2 and a negative 2. It's a positive and a negative value. So x equals 2 and negative 2 from this factor, because the square root of 4 could be 2 or negative 2, because 2 squared is 4, and negative 2 squared is also 4. And then here, same thing, x will equal plus or minus the square root of negative 3. We can simplify that. Square root of a negative, we take the I out. So it ends up being positive I square root of 3 and negative I square root of 3. Again, this is a quartic polynomial since it's x to the fourth, so we should have 4 solutions. Here's 2 and negative 2, and then positive I squared of 3 and negative I squared of 3. There are our 4 total solutions. I know this lesson was hopefully not as confusing as I think it is, but make sure any questions you have, you ask them in class. If we need to do 2 days of problems on this instead of just one like normal, then that's fine. We can do that. Don't be afraid to ask questions if you have any.